I and Harshith, today we are going to discuss about a real topic, that's digital signal processing. So our mentor is Dr.Anand Jatti sir. So today we are going to explain about digital image processing using by inverse filtering technique using OpenCV method. So I am Aditya. I'm going to explain about the same code and same program in Python Jupyter code, and Harshith is going to explain in MATLAB code. So now going to a project. So this is our main project. What we have done is, so as we all know, digital image processing is a method of processing where we interpret the image and analyze the digital images. So there are various techniques like selective blurring, erosion, dilation, and various other techniques. So let me explain the code one by one. So we have used OpenCV source for Python here. So before using CV2, we have to install the OpenCV software here. So I have given a command here in the command prompt, pip install OpenCV Python. So I have just imported here, and for getting the MATLAB plot for all the images, I have to install the library MATLAB .py plot. So I've installed it. And now before adding any before going to the program, we have to get our image, right? So I've saved the image in the document file. So here you can see I'm doing this program in the document file. So you have to save the image in the document file, and you can't save the image elsewhere. So you have to image the see here I have in document folder I've saved my image as Adi. So before going to that, we have to read the image from the OpenCV source. So I've given a command img is equal to cv2.imread adi.jpg. So it should be in JPG extension file for this code. So as we all know, for getting the erosion is nothing but it's a morphological function where it decreases the isolated pixels. So I've given the cv2 command here, and the kernel is nothing but the command that you see here. So it's just the same here. Dilation is nothing but just widening up the image, like zooming up the image, that is called as dilation. And opening to closing, as we all know, it's just a morphological function of the digital image. So for plotting, all the points here, I've just added plot subplot for plotting the subplots. These are just the quadrants here: 231, 232, 233, 234, and 235. And I've named every image as erosion, dilation, opening, and closing. So it's nothing but converting the original image to erosion and other properties. So what I give here is now I click on this. I give run.
Are you converting any image from RGB to gray?
Yes, sir. I'll explain it in the coming course. So here I get all the code. So this is nothing but grayscale image only. So here you can see, you can observe the plots here. It's 5 cross 5 matrix, and plotted in the mat plot. So these are the images: original, erosion, and dilation. So you can see here erosion. It has deleted all the isolated pixels. Only the image which is sharp it's given. Dilation, it's nothing but you just increase the pixel quality here. And opening and closing is just the morphological advancement here. So coming to the next code here. So as I explained here, we'll go in detail, describing all the features here. So from first, we going to the second code. Now we'll display the original image. So for displaying, we just give the original image here, and we give a wait key for the delay command. Now what we do, we convert the image to a grayscale image. Grayscale image is nothing but converting the RGB image into a black and white image. So BGR to gray image. I give a command here. So the next command goes like you have to display the grayscale image. So I give cv2.im, so that's grayscale image, and I give a delay command. The same goes to Gaussian blur also. So Gaussian blur is the selective blurring that we do for a proper imaging. So this is Gaussian blur, and I've given the matrix quadrants positions also. And for the blurred image, I give the same command. So it's all over the same also. Thresholded image is the quality of type of imaging where it's a type of imaging where when the intensity is greater, what happens is you observe a white color, and when the intensity of the image is less, you observe a black color in the image spot. So when I run this, so this is the original image that I have uploaded, and now this is a grayscale image that is converted to a RGB into a grayscale
What
image.
tool you have used for this? What code?
So the same code, sir. This code.
What is the conversion? Which line of the code does?
This one, sir. Gray is equal to CV2.CVT color.
Okay, it only does the conversion.
Conversion tool. Then this, then if I delete this, I get a blurred image. So it's little bit blurred. The background images are blurred. And
Have you done blurring?
sir, like I've uploaded the image. Then while uploading the image, I give a code here. CV2 Gaussian blur. So it's not complete blur. Like the background gets blurred and the image is like very sharp. So here you can observe here. Threshold imaging, you can observe here wherever the parts intensity of the light of the image, wherever it is more, you can observe white color here, and wherever the intensity is less, you can observe black color here. So this was all about the
Binary image.
binary image. Sir. It converts normal image to a binary image.
0 and 1.
0 and 1. So now. So this is also the same, sir. So this code I'll explain it with the help of a graph. Okay.
For that binary image, you have put any threshold?
No, sir. Only the intensity value available.
Up to 0 to 128, 129 to 250.
No, sir. Here I've
for the brightness.
Right. Here I've
Automatically it does or?
automatically it does. Sir. Only according to
No
the,
user-friendly option.
no,
You
sir.
can't assign.
We can assign, sir, but here I've explained it with the help of graph. See, if I run, it's the same code, but I'm explaining it in the form of a graph. So if I run this code, now I get the illumination intensity of the graph also here. So you can observe here wherever the image
That tool called histogram. Okay.
histogram.
Distribution of intensity.
In distribution of frequency versus intensity of illumination.
0 is the darker and 255 is the
brighter image.
Here in between
Yes,
the
sir.
shades will be here. Since the intermediate shades values are more.
So wherever the pixel quality is, like wherever the image brightness is, illumination is high, you can see here 250. So wherever it is dark, you can observe the slight change in the variation. So this is the same code that I have uploaded: eroded image, selective blurring, and threshold image. So this is all over the same thing. And just mention the axes here, just the quadrants 0, 0 for this 0, 1, 1, 1. So this is selective blurring. Selective blurring is just you blur the image only at the selected places and keep other images very sharp.
That is region of interest.
Region of interest, yes, sir. So this was all about the first two parts. Now coming to the second part, this program is only to show the negative image. During earlier days and all, we used to see like for taking a camera, for taking a picture, we used to get a negative film. Like we used to go to a shop and then we used to get it done. So this is the same property. We just convert the image from BGR to HSV color space by giving the same code. And then what we do, we give the threshold image, threshold value, the HSV image to get the proper color. So what do I do? The same code I'll run here. So you can see a negative color here. So during olden times, we used to get these frames. Nowadays,
That is the reverse assigning of intensity.
Intensity, yes, sir.
Where low is there, high
High.
is there. Where high is there, you are assigning low.
Low, sir. Yes, sir. So this was all about the digital image processing. Now I'm not going in detail for this. This is just a Py so that I've developed for Sudoku puzzle. You might have solved Sudoku in paper and all. So what do I do using image processing? If I give a unresolved image as a image here, I'll get the output. I'll get the desired output using Pygame. So what I've done, before installing, I have to install the copy and I have to install Pygame. So I've done this coding using reverse backtracking technique. So what happens here, Python, we have created a 9x9 grid here. So what we do, we define a function. So according to the function it works. So the code is a bit long, so I'll explain just in brief. So these are all the recursive function, and what happens here, according to the Sudoku puzzle rule, when we enter a number in the square, if the number doesn't hold goods in the square, it goes again to the backtracking technique. Like it goes to the previous square and it searches for the proper number. So these are the recursive functions that I've assigned, and these are the functions that draw the requirements for making the Sudoku grid, like how the grid is made, like x-axis and y-axis. Then after that, the coders for backtracking algorithm, I have used this algorithm. So as I told, if a number doesn't satisfy the Sudoku grid, it goes back to the backtracking technique, and then it gets the number, like it goes to the previous square. It displays the instructions here, like if I enter it, it will give false number, wrong value. If I enter proper number, it will give the correct value. So this is a very long code. I'll just explain in brief. So I've given I already assigned the number here using the image. So if you want to quit the Pygame, I've just given pygame.quit. So if I run the code here, I get a Sudoku image here. So I can type any number here, like 3, 2, 1, 3, not 3, 5, then 9.
One number will be typed only once.
Yes, sir. Like if I press enter, then I get the answer. So it's giving wrong value. So what I do, I delete this. If I press F, if I press D, it will go to the default value. So if I want all the answers, I just want to press enter. So I get all the answers here: 4824, 819. But why is it going? Why is it not staying in quantitative? Because it goes to the backtracking. So it will not display the value. I'm not displayed the like I'm not given the delay here. So it just gives an answer in just a few seconds. So not like for the user to enter his values, because sometimes what happens during Sudoku, we just go with the answer flow. We just don't try it by our own. So I'm not given the delay here. I've just given the answers here. So if I type any wrong value, it gives a wrong value. So if I type 3, 6, 1, if I press enter here, it gives wrong value because I've given 3 every time. So this is a wrong square. So it goes back to the previous square again. So I give default B for cancellation, and I give the if I want to know the answers, it will display 4, 8, 2, etc. So this was all about the digital image processing that we have done. Thank you.
Okay. One is something, some applications you select and work. What are the other applications you've gone through?
For digital processing, sir, I had gone through the audio signal processing also before that, but what happened is I couldn't load the audio file that got WAV version because the audio file was very long, and I found it very difficult to handle. So I went through audio signal processing. Then I went to speech signal processing, all the same thing only, but I found it a little difficult to.
Why you selected? What made you to select this one? What attracted you to select?
Because this is more of object oriented. What I feel is Python is an object oriented programming. So why I selected image processing is we can play with other images. Like we can know the intensity of the image, at what intensity is the quality. We can know about the quality of the pixel, like pixel quality of the image. So I was more keen into it.
Means that you will be getting results there only, that
Yes,
triggering me, making more interest.
Making more interest towards
means result oriented.
Result oriented.
Okay.
So even Sudoku, I found it very attractive.
What DSP logic you have learned? Signal processing logic techniques.
Signal is like selective blurring, Gaussian blurring, wavelet form. Like what happens here, I get an image that is a blurred image. I convert it into median filter, then adaptive median filter, binarization, binary image, and then I convert it into a proper eroded image, like sharp image. So here within the process, I get to know how the image is being converted from a blurred image to a proper clarity-wise image. So this was the concept that I learned.
Okay, good. Okay, thank you.
Yes.
I'm Harshith V, USN 017. I'm the team member of Aditya's group. Aditya has talked about digital image processing by using inverse filtering using OpenCV. I'm here to tell you about the concepts of digital image processing using MATLAB. Now, there are various concepts in digital image processing like region blurring, selective blurring, and various types of filtering. Then there are, you can also add 2 images, you can subtract 2 images, you can multiply 2 images. Now, all these concepts have very large, vast application. For example, if I show you a simple simple application of a simple signal process, digital signal processing concept, that is adding of two signals and subtraction of two signals. Now, this is a very basic which we learn in our third semester, fourth semester. Now, if I run this image, this is my figure 1, and this is my figure 2. So this is my figure 2, this is my figure 1, and I've added these two images on this image. So here I've taken random photos, so you might not think there is applications of this. But suppose if you're working in some Coca-Cola industry and where everything is automated, and suppose if a bottle is left unfilled, so how will you detect it? Because you are dealing with large number of bottles. So what you do is, this is this code is for image. I've basically written this code based on image subtraction. So the main concept here is I've taken one image here. I've saved this image in this file path, and another image this file path. So one of the image contains the image of a filled bottle, and the other image consists of a empty bottle. So here I've put a for loop because the bottles will keep on coming. We have to run it again and again. So if I run this, so what happens is, this is my image. This is my reference image. This is how my bottle should look in a Coca-Cola industry filled image. Now suppose in my factory, if this is unfilled and we can't do manually, we can't check everything. So what I have done is, using a simple concept, I have subtracted those two images. So as you can see here, I don't know if you can see through the glare, but here there is white portion and the rest all is black. So you can see this. So we can make conclusion that this bottle is empty. So you can by this you will determine how many bottles you are unfilled, how much losses you are undergoing, and etc. What is your factory's efficiency? Yeah. So basically this is it. Now I'll show you one more code where I've combined various concepts of digital image processing. So here, so as you can see, this image got blurred after some time. This is how I've applied. One second. So if I run this here, so here I've applied average moving filter. So what happens is, what happens?
It is processing some other image, I think, not this.
So no, there are multiple images. So here, this is my original image, and after some while it will get blurred. This is known as average image, average moving filter. Now here, as you can see, if I compare these two images, the original image and the sharpened image. One second. I think I will run a particular section. So as here, this is this is the average moving filter. The delay is very less. So what I basically want to tell you is.
No, why you cameraman photo wanted to add?
So this is different. I'll explain to this also.
You want to mix up both the?
Yes, sir. So here, this is basically an image. This is my original image. What I wanted to show you was there is another image which comes after this, which is more sharpened. So what we basically do is we apply low pass. We pass this image to a low pass filter. So we blur the image first, and we subtract that blurred image with the original image. So what happens is it gives an effect of sharpening of the image. So what this is, as Aditya talked about, selective blurring or region of interest. So what if I want to blur suppose only the head of this camera? Now I'll do this. And as you can see, this region is blurred. So this has various application in editing and various
In news channels you used to see.
Yeah, in news,
you don't want to
channels,
disclose
yes,
the particular person.
we can use this. So this is another basic application of DSP. And also this is basically the rice. I don't know if, so this is the rice image you have taken, and if you want the basic outline, this also we can do using these. So you come close. You can see the outline of this is you can
Blurred outline.
blurred outline.
Nice.
It can be seen. So another application of this is in PCB circuit boards. So what happens here? Here there will be a circuit board coming. 1 second. Yeah, here see. As you can see, all the wires. Now these are my. It goes off after it executes. To run it again. So here we can see all the pipelines have gone out, and all necessary images are like where suppose we there is a fault now, and we have an idea of where the particular fault may be. So but we won't know exactly where it is. So if you want to what do you call like lessen the number of like suppose if I know that my all pipelines are safe, all wires are safe, and there has to be a fault in my some kind of circuitry like in my motherboard or something. You can see, in that you can see all that rectangular images are all your basic circuits. So that indicates your so I'll show you again. This is that what I'm talking about. Here. So these are the main region of interest of ours. Like these are the main areas where we are interested in, and we can examine these areas. And these are all wires, for example. Like if we know that there is no problem in these, we can for the time being neglect these and focus our concentration on these areas.
Based on what data distribution it will select that portion is brighter and this thing.
Basically.
Any threshold, any region of interest?
Yes, sir. Here the MATLAB has here I've run this thing. There's a function called the IM erode. So what it does is I've taken a circuit TIF file, what do you call a picture. I've loaded it here, and I've taken a variable called SE, and I've put it intensity like I've run it in follow from I is equal to 1 to 25. So from there it can keep on running the follow up till the follow ends. So based on that it blurs it shows what all we are considering.
Okay.
So this is the subtraction that Coca-Cola bottle, and this is the addition of two signals, and this is that's it.
Okay. Main learning DSP technique.
So like image erosion, then basic concepts of DSP like addition, multiplication, then blurring, selective blurring, region of interest. Basically I've tried to incorporate what we learned till now in.
Okay, any such applications further? You want to cashew or any grains or food quality grading, grapes grading through imaging rather going to industry or farmer's land. You can acquire image, you can grade them. Quality 1, quality 2, quality 3. you can tell your representative, send me the image, whether from that particular farm, whether I have to take grapes or not to take grapes. Tell him to send the image. You can
One more application of this
grade
is
quality, import quality, export quality, how they will do, how they will process and they will send, they will do that process. Okay, quality 1, quality 2, quality 3. Example in cancer also, cancer stage 1, stage 2, stage 3. How you write the code, according to that you can grade it, you can do it. Like many more such applications.
maybe like for example, there's application in parking lots for detecting empty spaces and like filled spaces. That like that'll be very useful in if you can integrate it with a website. Suppose using image processing, you can scan the whole parking lot and the empty slots can be detected using different color and the filled slots using different color. Based on the number of patches or number of colored slots, you can show it on the website. So customers can already see on the website whether there is parking space available or not. So they can they can do it on the way only, so they don't have to go to the particular parking space and waste their time.
Okay, thank you.